Okay, in this video, we're going to be doing some practice problems relating to series and parallel circuits. So you're going to learn how to apply Kirchhoff's current and voltage law as well as Ohm's law to solve for unknown variables within the circuits, including resistance, voltage, and the current. So there's two scenarios presented. One's for series circuit, one's a parallel circuit. Now I'm going to go through these, and then you're going to get a chance to actually work on some practice problems yourself. So our first scenario is a series circuit, and the series circuit presents a 12-volt power source. Is in a circuit with three different resistors, R1, R2, and R3. Okay, and then IT is going to be the total current. So the first problem asks us to find the total resistance. So if we remember, one of the rules for a series circuit says that, so this is RT, that for RT, you simply add up the resistances. So R1 plus R2 plus R3, right? So those values are given to us. So RT would be equal to 220 plus 470 plus 1200 would give us RT would equal to 1900 ohms. Okay, so the first problem is going to be 1900 ohms. The second problem says that the current flowing through each component. So find the current flowing through each component. So IT, I1, I2, and I3. And I1 is the current flowing through resistor 1. I2 is the current flowing through resistor 2, and then so forth. So if we remember, one of the rules states that the current for a series circuit is going to be the same throughout every component. So it's going to be the same through the voltage or the power source in each of the resistance. So we simply have to solve for the IT, and that would equal to I1, I2, and I3. So if we remember Ohm's law, right? So with Ohm's law, we can say that the I total is going to be equal to the V total divided by the R total, okay? So if we solve the current, basically what we're doing is solving the current coming through this battery source here. So this is IT, and that's going to equal to the current going through this resistor. It'll also equal to the current going through this resistor and the current going through this resistor, okay? So we know what VT is. We know that VT is going to equal to 12 volts. We also know what the RT is because we just solved for that, right? So that was 1900 ohms. Okay, so if we do the math for that, we come out with 6.3 milliamps, okay? So the current flowing through each component is going to be 6.3 milliamps. And if you remember back to our prefixes, milli simply means 10 to the negative 3. So all this is saying is that we have 0.0063 amps. So you can do it in milliamps or you can do it in amps. All right, the next problem states for number 3, what is the voltage across each component? So the voltage across each component, it's not the same as the current. So we can't calculate the total current and say that's equal to the current through each of the different components. We actually have to calculate the voltage through each component individually. And then we add them all up, and that gives us our VT, right? So the rule states that for a series circuit, voltage total is going to equal to V1 plus V2 plus V3. So we need to solve for what those values are going to be. So we know VT is 12 volts. So V1 is going to go across resistor number 1, V2 is across resistor number 2, and V3 is across resistor number 3. So we can use Ohm's law in order to solve for the individual voltages because we know R1, R2, and R3, and we know I1, I2, and I3, right? So what we can do is use Ohm's law. So V will equal to I times R. Okay, and we can do this for each of the different resistance components. So if we say V1 is equal to I1 times R1, so we could say that 6.3 milliamps times 220 ohms gives you a V1 equal to 1.39 volts. Okay, so V1 is equal to 1.39 volts. And we simply do the same thing for the other two resistors. All right, so we know we're still using the same equation, but now we're going to say V2 is equal to I2 times R2, and that equals to 6.35 milliamps times 470 ohms, and that gives you 2.984 volts. So V2 is equal to 2.98 volts. And we do the same thing for the third resistor. And when we do the math, we're going to find out that V3 is going to come to be 7.6 volts. So we know VT, that's given to us, which is 12 volts, and we've just solved for V1, V2, and V3. So number 4 says verify using Kirchhoff's voltage law. So if we did this correctly, right, then the total voltage that we got from V1 plus V2 plus V3 should equal to the 12 volts that we were originally given for our voltage total. So let's add that up. So 1.39 plus 2.98 plus 7.6 indeed gives you 12 volts. So we have verified that V1 plus V2 plus V3 does equal to 12 volts. Okay. So those are the problems for the series circuit. Now we can move on to the parallel circuit. So let me go ahead and erase all of this. Okay, so parallel circuit, it gives us the power source is 15 volts. We also have 3 different resistors, but they're arranged in parallel. So the first thing it asks us is to find the total resistance. So the total resistance for a parallel circuit, we did talk about this, and we talked about how the equation wasn't very user-friendly, right? So we said that the total voltage for a parallel circuit would equal to 1 divided by 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so what that would look like for this particular problem, it would be 1 divided by 1 over 470 ohms plus 1 over 2,200 ohms plus 1 over 3,300 ohms. And if you do the math for that, you'll find that the voltage total is going to equal to 350 ohms. Okay, so RT will equal to 350 ohms for this particular parallel circuit. So the next problem says find the voltage across each component. So the voltage across each component for a parallel circuit is going to be very similar to the current for a series circuit, which basically means they're all going to be equal. And we know what VT is, 15 volts. So the voltage across V1, the voltage across V2, and the voltage across V3 is all going to be 15 volts. Okay, so the next problem says the current flowing through each of the different components. Okay, so current flowing through each of the different components for a parallel circuit is going to be I1 plus I2 plus I3. So we have to solve for each of the different currents individually using Ohm's law. And Ohm's law says you can solve for current by saying the voltage over the resistance will give you the current. So if you do that for each of the different individual components, all right, so let's just do the first one. So I1 will give you V1 over R1, and we know that V1, right, because we solved it, was 15 volts, and we know that R1 is 470 ohms, and that's going to give you an I1 equal to 32 milliamps. So you simply do that for all the different components to get the I1, the I2, and the I3. So I1 will be equal to 32 milliamps. The I2 would be equal to, and you're going to have to verify this, but the math will be the same for all of these, 4.5 milliamps. 6. And then it says verify using Kirchhoff's voltage law. So Kirchhoff's voltage law would simply state that if you add up all of these I1, I2, and I3, it's going to give you the total current across the power source, right? So I1 plus I2 plus I3, which is 32 milliamps, plus 6.8 milliamps, plus 4.5 milliamps will give you 43 milliamps. Now, if we want to verify that with Kirchhoff's law, we need to find the total current going across the battery source, right? Which is right here. So we know VT is 15 volts, right? And we just solved for RT because we said RT was 350 ohms. So now we can solve for IT. So IT, according to Ohm's law, would be VT all divided by RT would give you 15 volts all divided by 350 ohms, and that would come out to 43 milliamps, which indeed is in line with Kirchhoff's law. Okay, so those are some examples on how to actually use the concepts that we've learned in order to solve for some problems, and you're going to get to do that on your own shortly.